inverse log property, okay? The first part is if you are having an exponent, raise a logarithm, right? That means what? If the base number and the base of the log are the same, then whatever the number in here is, that will be your answer. And later we're going to analyze that one. Second part, if you have a log raised to an exponent, if the base and the number in here are the same, then the answer will just be that exponent for such. Also, the change of base logarithm tells us that if we have log base p of q, then we can just split the p and the q into two separate logs, right? Whether that be common log, natural log, or log of any base. And how do we use that one for such, okay? Let's answer this one in here, number 39. Okay, let's read number 39 in here. Let's read the instruction first. Kinsey, go ahead.
For the following exercises, use the definition of common and natural logarithms to simplify.
Thank you, right? So in number 39, we got this one in here. So if we have e to the ln 1.06, that can be written as what? ln is defined as what? Log base e of 1.06. Are we good? Right? So again, we change ln to log base e. And according to this one, what kind of inverse log property are we using? Are we using the first part or the second part? The first part, right? As you may notice in here, since this base and that base are the same, right? Then that means the answer is automatically what? 1.06. Are we good, guys? Similarly, for number 37, if you have 10 to the log 32, again, that's a common log, which means if there's no base, automatic, the base is what? 10. Very good, right? So again, if there's no base, automatic, this is base 10. Common log, right? And again, by the inverse log property, again, inverse log, the base and the base in here are the same, then automatically the answer is going to be what? 32. Are we good, guys? Okay. Lastly, number 38. I'm going to put number 38 in here and let's analyze number 38 in here, right? So for number 38, we got the following. What's that? 2 times log of what's this? 0.0001. 0.0001. Okay. First of all, if there's no base, automatic, what is this? 10, right? Common log, right? So automatic, that's base 10. So in short, I'm gonna express this as what? As power of 10. How can you express this as a power of 10? Well, if it's read as a decimal, what's this gonna be? Tenths, hundredths, thousands, 10,000s, right? So this is read as what? 1 10,000s. Are we good? Get it, guys? Once again, this is decimal. Tenths, hundredths, thousands, 1 10,000s. Right? So that means this one expressed as a power of 10 can be written as what? 1 10,000s, right? Are we good? Right? Again, as a power of 10, what is that? How many decimal points? -4, right? 1 over 10 to the 4. Are we good, guys? Get it? Don't forget the 2. Are we good, guys? Based on negative exponent rule, what's this gonna be? 10 to what power? Negative 4 power. Good. All right. Log base 10. Now, according to inverse log, right? Second part of inverse log, right? If the base and the number are the same, then what's the answer for this one in here? What's log base 10 of 10 to the negative 4 power? If the base and number are the same, then the answer will just be the what?
Negative.
The exponent, negative 4, right? So whatever that answer is, negative 4. But again, you multiply it by 2, right? So what's the answer, guys?
Negative 8.
Negative 8. Okay. Again, we're trying to do this one this way because it says in there algebraically, all right? But again, you can verify the answer on your calculator as well. Are we good? All right. Questions regarding that? Let's analyze some more in here, okay? Let's try number 45. Okay, let's try number 45 in here. And this will be the thing that I'm going to put for such expression. Number 45. It says, number 45, 6 times logarithm of 8. All right? 6 times logarithm base 8 of 4. Okay? So the first thing that we're going to do in here is first thing that I'm going to do in here is this, right? Oh, so this is 8 and that is 4. Can we express this one as a common factor of, or a common base of something? What do you think? 2, right? 8 can be written as 2 cubed, right? Okay. 4 can be written as 2 squared. Okay. Are we good, guys, with what we did? Right. So 6 times log base 2 cubed, that's 8, of 2 squared, which is 4. Once again, we express 8 and 4 as such because they're both base 2's. Get it? Okay. And with that being said, by change of base rule, then we can just write this one as follows, right? So I'm going to put 6 in here. Now I divide this 2 as such, right? On top, I'm going to put log 2 squared, right? At the bottom, I'm going to put log what? 2 cubed. Are we good, guys? Okay. Now what do we notice in here? They can cancel out, right? If we put in base 2 on both sides, then that means what? Okay. This and that is going to cancel. Hence, it's just going to be what? 6 times 2 on top and then 3 at the bottom in here. Good. Once again, we are using what? Inverse log rule. Are we good? Right? So we just use inverse log rule in there. Log 2 squared on top, log 2 cubed below. Well, the log 2's will cancel, right? Because of that, the 2 and the 3 will remain. And just multiply by 6, right? So what's the final answer for such? 4. Very good, right? 6 divided by 3, 2, times 2 will be equal to 4. Very good. So again, we just did this one algebraically with the help of a little bit of change of base log rule and inverse log rule. But once again, you can verify your answer on your calculators as well. Are we good? All right. Thank you. Any